Okay, let us then go ahead and talk about the class itself and really what the class is going to all be about and kind of get you going in the right direction. If you are registered for the class in Access and the class is listed as 120B, 220B, you can go ahead and find us and find the coursework website. And on the coursework website, you will actually find syllabus and logistics and some examples. And we try to keep on posting everything through the coursework website. You can get them access to you. I'm just going to kind of take a look at some of these documents together. Not spend too much time on them, hopefully, because I think for some of you it's all pretty familiar if you've already taken 110 or 120A, some of those early classes. Okay, let's see how this works. Okay, in terms of what we're taking, so this class is actually designed to be a follow-on to the Introductory Building Information Modeling class, and the idea is to go one step further. Kind of address the fact that we could only get so far in those first sessions in terms of getting the basic building elements out and putting them together into something that looks like a building. But there's really a lot further you can go in terms of understanding buildings, a whole series of different interrelated systems, and really start to think about how the structural system and just all these different mechanical systems, from moving air through the building, moving water through the building, all those things get designed and modeled, and how you can use building models to go through and help you with design analysis so you can size them properly and really just kind of inform your design. The whole idea behind everything we're doing is really all about informing your design so that as you make design decisions, it's not strictly aesthetic or just based on hunches, but that you can actually do some of the engineering and the analysis to understand what the performance is predicted to be, and then use that as a guideline for sizing systems and designing and putting them all together. So along those lines, we created this class, which is really going to cover both sides. This class is going to be a little bit different than 120A or 110A, depending on when you took it, in that it won't be strictly computer modeling. We're actually going to cover a fair amount of just really the physical principles and design criteria, and really give you a lot of what the building code says, what science says, what all those different things that sort of dictate why we design systems the way we do say we need to go ahead and put into the system. So there'll be some theoretical just in terms of understanding why we're designing things that way. But then we'll also go through each of the different types of systems, show you how to model it as part of the computer model, how you put it into a BIM model, get all the right pieces connected and together, and then also use the model to drive analysis. So when we start talking structural systems, to actually do the analysis of the structure and get feedback about the proper sizing based on the structural criteria. The same way when we start talking about mechanical systems, to actually, based on the spaces and the thermal properties that you're trying to create, and the thermal properties of the materials you're putting in there, how do you actually figure out how much air you have to move and how big that system is going to have to be, how much energy you're going to consume. So we're going to be looking at kind of a little bit of the engineering as well as just the computer modeling, and hopefully it'll really take you a lot further in terms of understanding just how buildings work and come together. So some of the big types of systems we're going to be looking at are, we're looking at some of the things that are sort of more the architectural systems, really looking very carefully at the building envelope, the skin of the building, the walls, any fins, any light reflection systems, the window characteristics, panelized windowing systems. We're going to take a look at access systems, so things like elevators and escalators and stairways, and really what dictates where those things have to be and how big they have to be and why they're located there. But then we're going to get into a lot of what are traditionally thought of as the MEP systems. Okay, well, shouldn't have skipped past structure so quickly. We'll be looking at the different types of structural systems for gravity loads as well as for kind of lateral loads. Then get into mechanical systems, electrical, and plumbing and fire protection systems. So it's pretty broad. It's like all those different things that work together, like to ultimately integrate into a complete building. Okay, in terms of where we are going to be, I'll adjust this. Looks like it's going to be, say, 5:15 to 6:45, something like that. We'll be meeting here in the Y2E2 cluster. We have a teaching team that includes a lot of different folks who are very talented. We have Raj, who is right here, who is the TA for 128, is going to follow us through and going to keep us going in terms of support there. Lottie is also going to be joining us next week when he gets back into the country. We're also going to be joined by Dimi Firmakis, he was a student who graduated about 2 years ago, I believe. He actually does an awful lot of consulting on building systems integration in Greece, where he's located now. So we're going to be bringing him in remotely as a mentor and to help teach things through GoToMeeting a lot. Okay, so we have a lot of different folks who are involved. We have email addresses here. We also have some contact information. That is my phone number that will ring through to my cell phone. So please go ahead and use it judiciously. You're welcome to call it when you're in a panic and you're worried about how things are going. One of the big rules in this class in general is don't panic. A lot of times computers fight with you and they do weird things. And when that happens, there's almost always some way to go ahead and rescue you. So just don't panic. You rarely lose everything. It all kind of comes together. But if you do need some help or you have questions, you're welcome to call or send some email. We're also going to set up, just as a way of communication, we'll use Piazza again. It actually worked out pretty well as a site for us to post questions and share answers. And it actually kind of works pretty well. You just post things, and the first one of us who actually sees the question will typically respond to it. And you get answers, and you can kind of respond to each other's questions. We don't really have office hours in the classic sense as much as we have what we'll call lab hours, which is we tend to hang out here in this room answering questions and just trying to get you to some of the different assignments. So we'll post when those are happening. We'll pretty much be some lab hours every week. And it'll kind of be typically in the evenings or some of the afternoons, kind of relative to when the assignments are due. In terms of assignments, okay, everything in this class is really all about going through and completing some projects. And last time we got 5. I would say this would be 5 or 6. We never seem to make it to the 6th. There'll probably be 5 or 6 design projects that'll involve some amount of modeling work, and most of them are to be completed individually. But last quarter we had 1 that still involved working in a small group. All the assignments are supposed to be turned in by midnight on their due date. There's no midterm or final exam, which is usually a pretty good thing. We try to get you all finished up during dead week or end of quarter period. Okay, get your final projects turned in there. And as we're doing all this stuff, I'll kind of repeat what most of you heard me say from the first class. It's actually very difficult to go through and grade what's going on in the class, because what ends up happening is, for so much of what's going on, if you're doing design work which is incorporating the principles well, is a good model that actually kind of shows how to use it, what am I going to say? It's you tend to do okay. It's one of those, I think most people who have been in the 110 class sort of know that if you get the assignments done and you go ahead and turn them in on time and you've done everything it's asked for, you tend to do okay in the class. It really sort of works its way out. This is not one where we try hard to go ahead and sort things out and have a huge distribution kind of curve that really tries to separate the highest from the lowest in terms of the grading. I'm not big on really sort of pushing the grading aspect. So in general, if you do what's expected, turn it on in, get it all in there, you tend to kind of do okay in the quarter for finishing up. Now, the only thing you can do to get yourself in trouble is not turn things in or turn them in really late. Okay, so late submissions actually do get penalized. Okay, Lottie and Raj, you came up with an interesting policy last time. Why don't you go ahead and explain how that worked? Your buy. You just had one assignment you gave grace on.
Yeah, so for one of your assignments, say you're really busy with other courses, you could take in a late class and submit it up to a week late. And you will not be penalized for that particular assignment.
Okay, so use this judiciously again, because it's kind of a really kind of neat thing. The advantage of it is you can sort of spread your work around when you get in one of those really panicky situations and you can't get it all done. The bad news is it kind of catches up to you eventually, because you still have to get the next assignment done. So, you use it carefully or keep it in your back pocket as long as you can. And then use it. Because really, one of the few ways that people do get in trouble in the class is if you sort of get behind on one thing, then the next one comes rolling around and it starts this cascade that's just going to get you in trouble. Okay. An important thing about testing and grading and the time guidelines and stuff like that is, I will warn you, and I think most of you know this who've done the building modeling class, this stuff gets to be really addictive. Okay, to the point where on any assignment you get tempted to go ahead and spend hour after hour endlessly improving and incrementally changing your models because there's that one little thing that just isn't quite right, and you want to fix it because you're seeing it in 3D on the screen, and you feel very intent on really making that model like perfect. And we're going to fight that again, because it's something we always can end up needing to fight with all this stuff. And that, for all the assignments, there's some guideline about the number of hours you should be spending on it. And when you sort of hit the wall on that, feel okay about just turning it in. No model that I have ever produced that has actually been built has ever been perfect. There's always little sort of flaws and known defects and stuff like that in them. Because you just don't have enough time between now and the end of the quarter to develop full, perfect models. No one really has the time to do that. So go through and allow yourself the latitude to go through and get the intent of the assignment done, kind of put it together, but don't necessarily worry about excessively perfecting things, because it really does get to be too open-ended, and you could easily 40 hours in, just stop. It's time to stop. Step away from the computer and just turn it in, because it's really, it is addictive. Okay, what else do you need to know in terms of getting started? Class schedule. Let's show you what's actually going to be happening here. Here's a rough outline of what we are going to be doing across the class. So we're starting out with some just course overview. We'll talk about buildings and systems and performance-based design, but then we're going to go just through a lot of different things, thinking about just really how these systems work together. Starting with the whole notion of the context in which we're placing our buildings, so the climate, some of the basic principles for comfort and how we design towards that, how we can actually think about using the context of our building to do a passive design that doesn't really use an awful lot of active systems, but actually takes advantage of the natural climate and the natural environment, how we can start thinking about using those things before we get into active systems. We'll follow right out of that into really thinking about the characteristics of the building envelope, thinking about the walls, the roofs, how heat's flowing through those different surfaces, the type of energy use prediction analysis we can do, and then start getting into more kind of thinking about, in particular, what the effect of the sun is on our designs. It's actually one of the most powerful energy sources that affects our buildings. Thinking about how we can kind of deal with shading, deal with reflection, and think about it in terms of its daylighting considerations, because whenever we can go ahead and put together a building design that is sympathetic with the context, we just ultimately are creating a better building. We're working with the environment as opposed to fighting the environment all the time. So we're going to start with just thinking about how we design buildings relative to that. We'll also go ahead and take a look at the notion of circulation systems. This is one that is particularly near and dear to me recently. I was just at this convention in Chicago where in this 35-story hotel, basically 1,000 people had to get on down to a ballroom essentially at the same time for a convention, whatever, to start. And there were 6 elevators. And it was just amazing to watch how this whole system worked or didn't work relative to this, because elevators, stairways, they're all designed with particular design loads in mind. What happens is if they get overloaded or if unusual loads kind of hit the system or something like that, there were really literally people waiting in line for an elevator for 30 minutes having fist fights. It's just it's really amazingly, or can be amazingly bad. So elevators, escalators, stairs and ramps, how all those work in terms of providing circulation to a building. We'll spend a day looking at that. We'll get into structural systems, which I know is a favorite topic of many of you here in the room. We'll look at the gravity-bearing systems, thinking about, we never really got very much of a chance to talk about foundations before, just really get deeper into beams and beam systems, take a look at truss systems and how all these things ultimately get used in analysis tools. So we get some feedback about our sizing and just really try to think creatively about how we go ahead and create structural systems that support different types of buildings. Some of the much more creative designs that we're seeing these days, where everything isn't rectangular and isn't going straight vertically. It starts having interesting forms and shapes, and how you have to adapt the structure to go ahead and work with that. We'll also be looking at lateral load systems. So thinking about how we're resisting all those wind and earthquake loads, thinking about bracing systems, how we model shear walls and cores, and again, how that factors into analysis. And we'll also take a little look at structural detailing. So that's something that's always frustrated a lot of people when they're working in BIM models, is that you have these structural elements and they sort of come together, but they don't quite come together. They seem to hover a few inches away from each other, and it doesn't show a lot of the detail. And we'll actually show you how we actually incorporate that stuff, both in terms of the steel frame detailing as well as the concrete detailing of the rebar and how it gets incorporated into the model too. Thinking about how we do it in 3D as well as how we actually pull that into 2D. We'll get into mechanical systems, thinking about your thermal comfort and thinking about ventilation systems and how we move the air throughout the building, as well as heating and cooling. So once we are moving the air and keeping us the air quality pretty good, how we then go ahead and control it so that it is the proper temperature for what we need at different times. We'll look at forced air systems, we'll look at hydronic or water-based systems, as well as radiant heating systems, and how you do that kind of modeling and ultimately analyzing those things. Then we'll actually take a look at a couple different ways of analyzing. We'll kind of use some of the simulation and sizing tools that are right within the BIM modeling platform, as well as take a look at something called computational fluid dynamics, which really lets us go through and start to understand just the very detailed airflow through a space. So if we are introducing warm air either through the floor or through some ducts or through some chilled beams, really understanding how it fills and moves through the whole space. That really actually has a very big effect on the sizing of the system and really how you can design things to make it more comfortable for people. We'll be looking at plumbing systems, both the water supply and the waste side, and really think about those. But then also take a look at plumbing systems in sort of a more sustainable way, really taking a look at how you design a gray water system so that we can reuse some of the water as opposed to just putting it all down the sewer, as well as looking at things like rainwater collection and storage systems and how really ultimately we, for a building, analyze and predict the water use, relative to a standard system or some innovations that can save some water. Really try to do some predictions that get into sort of lead evaluation. Fire protection. We'll both look at the whole issue of fire resistance and how people leave a building, how the egress works. But we'll also look at alarm and sprinkler systems, how those actually get designed. When we need to go through and extinguish the fire, whether it's going to be a water-based system or a gas-based system. Electrical systems. Electrical systems tend to fall into, think of as power, so high voltage and line power for plug loads and just kind of typical needs in the building, as well as low voltage and signaling systems. So we'll look at basically how we model those things and how really the modeling tools can help us as we indicate what all the different loads are, sum up those loads so we can actually size up how big the panels need to be, and understand really how much energy is being drawn by all the different sources that we put in the building, or all the uses we put in the building. Then we'll look explicitly at lighting, because lighting is kind of a very interesting one in terms of how we use daylighting, how we use electrical lighting, and how those two things can kind of work together. So that you can place lights well, understand how much light is going to be thrown, and understand how light reflects through a space. How we can maximize that. Kind of like really work on the loads there. Finally, we will do a little bit of systems integration and coordination. We're actually going to be doing that a little bit throughout the quarter. So every step of the way, we're going to be looking at individual systems, and we'll always be thinking about how they tie together into a more cohesive whole, just how all the systems are actually fitting. And we'll specifically look at the issue of really how we can identify clashes and then ultimately resolve those clashes. So getting into a lot more detail than we do very quickly in one can. It'll be a final project, and we'll work on that, and finally at the end we'll do some speaking presentations. So that's kind of the quickie overview about what's going on. So you got the kind of full range of all these things working together. Sort of makes sense? Okay, beautiful then. Let me go ahead and put the syllabus away. Do a little bit of course logistics. I'm not going to spend hardly any time at all on this because most of you are familiar with this stuff. But just for the people who are new and haven't worked in here before, to get access to Y2E2 184, basically you need access to the building. Okay, and everyone will get added to the list to get access to the building after hours and on weekends. Then to get into this room, you need this code, 113751, which works on that little door over there. So if you have access to this room, super. Come on in. Anytime that things aren't happening in class, you're welcome to come in here and work. Okay, there's also the Architecture Studio up in room 266, which has all the same software loading on it. So if you're an architecture student and you have access to that room, go for it. That's another good place to work. There's also the Sci-Fi iRoom upstairs, and if you're a construction student or you have access to the iRoom, again, all the software is available and loaded up there. So really work wherever you want to work. Or what I highly recommend is load it on your own computer so you can really work wherever you want to work, because all the software is freely available. And again, in terms of logging onto these machines, I think most of you are familiar with that now, just logging in with your SUNET ID and password. And then what happens is when you log in, you actually have a little AFS, an Android file system volume, which is mounted to your computer. So that allows you to carry your work with you. So if you work on this computer today and that computer tomorrow, your documents folder sort of follows you, which is kind of a nice thing. But I do highly recommend playing it safe. Yeah. Also, putting things on a thumb drive or USB stick, something like that. As well as I know a lot of people use Dropbox or Box or a lot of different systems like that. So it's definitely worthwhile to kind of back things up in the cloud somewhere. In terms of the software that you're going to be using, there's a couple of big titles that most of you probably already have loaded on your machines. If you have taken 110 or 128A, Revit 2014 is probably already sitting on your computer and it's got to leave it there. So you're going to keep on working with that. We'll also work with Navisworks Managed, which some people did or didn't load up at the end of last quarter, but that's a really good tool for doing coordination between all the systems. So go ahead and download that. We're also going to be working with a couple of tools, especially when we get started. Typo right there, should be 2011. Vasari, which is a tool specifically for doing conceptual modeling and analysis, energy analysis, and wind analysis of those models. So there's a place where you can download it there, as well as Ecotemp analysis. So those are two tools that are really good for doing environmental analysis. We'll get started there. But I highly recommend ultimately installing all these things. What happens is if you want to install these machines, you can. They're all available free of charge, or on these software packages. If you go to any of those kind of URLs, it'll take you to the Autodesk Education community. And within there, you'll find, like this is the place for Navisworks. Get a 3-year license today. You are eligible. Choose your version. Choose your language. Choose your operating system, and then install now. What's it doing with me? Am I signed in? Looks like I'm not signed in right now. It might have signed me out. Yeah, it says I'm in. Oh, there it is. Just took a minute for it to load up. What will happen is when you go out there, it will issue to you a serial key and a serial number of a product key. These are good for like 3 years, something like that. So go ahead and download those. It'll also send you an email message with that information. You don't need to worry about writing it down. But within here, I'm used to this being actually, it must be because I'm on the Mac side right now. If you're on a PC when you do this, you'll see it says install now or browser download. Install now will just put it right on your machine at that time. Browser download will download a file that you could run and then put those numbers into later. But go ahead and download like all this fun software. Get it on your machines. We'll have it on these machines, okay, so that it's available for you in the lab here as well as upstairs. But I highly recommend just having your own machine, or at least having a good workstation where you can work quite independently of anything that's going on in here. So think about doing that. Where do I want to go? Let me go back over there. Oops, not that far. Okay, there's some instructions here just about installing the software, but I think most of you can follow along pretty well. Just once you get going in terms of doing the installation, it kind of just works in terms of what's going on. If you are working on your own machine, though, let's talk about that. You have the option of installing all this stuff on a PC. So if you have a PC laptop computer or a PC computer at home, a Windows-based computer, all these things are Windows-based. If you have a Mac, and some of us have Macs, I have a Mac, and we need to kind of accommodate that too. There is another handout that explains your options there. So, in terms of installing all this software and thinking about doing it on a Mac. Okay, actually, I find out if anyone's here who hasn't already done this. Is there anyone here who has a Mac, who wants to install on a Mac, who hasn't already done this before? Unless you've already done this in terms of Bootcamp or Parallels or something like that. No embarrassment. Okay, yeah. Bootcamp, if you want to go through and if you have a machine that doesn't have much memory and you don't mind rebooting your machine as you switch back and forth between Macs and PCs, Bootcamp works very well. If you have more memory available and you want to be able to kind of move back and forth pretty quickly, keeping both systems open, then I recommend Parallels. Either one works. Okay, and yeah, they're both available for Parallels $39.99. Bootcamp's available for free. But you still need a copy of Windows somewhere, whatever. It sounds like most of you are already taken care of, so I won't belabor the point. But if you need help getting set up, getting your software on a Mac, like, talk to us, because we can help you figure that out. There's really, I don't know, it's not that bad, but there's a couple little steps involved in doing it. Okay. I think that's pretty good on the logistics side. How about from your perspective? Let me answer questions. Oh, logistics folks. So people who are thinking, does anyone have any questions about 120B versus 120S? Do you know about 120S? Okay. 120S is for people who didn't take A, or 110, they didn't get a chance to take that. If you want to get started from the very beginning and kind of see what the whole introductory BIM class is like, and you'd like to take it now as opposed to waiting to next fall when it's going to be offered again live, it's available for you online. So go ahead and like download, watch all the videos. We recorded all that stuff fully. So if you haven't taken 110 and you want to get started, 120S, or is it 220S? I think it's only 220? 220S. Go to that. It says you can sign up for taking the class anywhere from 2 to 4 units. We'll watch the videos, kind of do the problems, projects offline at your own pace, and get credit for that one. Okay, so if you haven't had any prior BIM experience, you may want to consider doing that. Yeah. If you haven't had any prior BIM experience, again, don't be dissuaded from taking this class. This class is, we're not going to spend as much time on the BIM basics, but a lot of what we'll be doing, I think you'll be able to pick up in context as we go. Because once you see you kind of mess around with the BIM system a little bit, a lot of the features tend to work very, very similarly across all the different tools. So it's pretty easy to just pick up on the fly. Okay. So 120 or 220S is the independent study. 120B is what we're doing here. Okay. In terms of this class, hey, we didn't answer this one about units. Because
yeah, I think there are a few people who want to take 220B for 1 unit.
Ooh, that's an interesting, because somehow in your schedule, like you only have 1 unit left over. Now, I understand the situation. That's kind of a tricky one, you know, in terms of.
Like edit 220S to accommodate.
We could definitely have them sign up through 220S in terms of doing it that way. I'm not sure if I can change this one down to 1 now. It's kind of an interesting one. It's kind of interesting about how to reduce the amount of work to really make it, like 1 unit's nothing. That's usually like a seminar or something like that. You know, you are
I think they're not concerned about the work. It's more of,
trying to work up against the limitations.
About 10 units and they'll have to pay more.
No worries. If you are in that situation, if you are up against your 10 unit limitation and you really just want 1 unit, go ahead and sign up for 220S. Come to this class, and somehow we'll keep track of that. And, yeah, because how you register is really kind of independent of like what we're actually doing. So go ahead, yeah. If you need to register for 220S for 1 unit, go ahead and do it that way. Does that make sense? Does that affect a few people? Couple? Yeah, so if you need to do that, go ahead and do that. That'd be fine. In terms of, yeah, because...
Yeah, it's right now not set up for 1 unit, but we speak to Jill.
It's still set up for like 2 to 4?
Yeah, it's still set up for 2 to 4.
That I think we can change. Okay. So if you need that, okay, very good. And if you're signing up for 220AS, go through and send me an email message, and I'll give you a code, because you actually need a special code to register at the time when you do it on Access. Okay, so if you're in that hole, we can try and like get you through that hole. Yeah, we'd rather have you here and take in the class, and we'll work around the units limitation. Okay, yes? Yes? We're going to do our best to accommodate that as much as possible, although I don't think there was many variations this time. Like for 220, I'm trying to remember. I remember seeing someone signed up for it like in for 2 units. Yeah, we'll try to give guidance so that depending on the number of units you signed up for, the assignments will be appropriately scaled. Okay. Working on tuning that. We did pretty good last quarter. I think it wasn't too bad, but like it's a negotiation. We'll work on it in terms of trying to make that work together. Other logistical questions? No? No other questions? Okay, cool. Very good then. Enough of all that. Let's just go ahead and talk about buildings and think about them as a series of systems and how they actually sort of work together.